Hi grade 9s, welcome back to another one of our video lessons. So today we're going to continue with constructions. On page 118 we're going to learn how to construct quadrilaterals, or rather a parallelogram that is a quadrilateral. Okay, remember quadrilateral is a figure with four sides. A parallelogram is a figure with two parallel opposite sides. So these two are parallel, these two are parallel. Okay, so we're going to learn how to draw one of these parallelograms. Okay, so I'm going to go through the worked example on page 118. So it says parallelogram ABCD has AB, which is 5 centimeters, angle B, which is 30 degrees, and angle BC, side BC, which is 10 centimeters. So basically, if they give us, or if someone gives you two sides of the parallelogram, and an angle, you can always draw that parallelogram. Okay, so remember what I said, the parallelogram, the properties of a parallelogram is that two opposite sides are parallel. Okay, so that's the same parallel as that, and that's parallel to that. Okay, so now they tell us two sides. Well, remember, if these two sides are parallel, then, and these two are parallel, these two are equal, and these two are equal. We'll discover that through doing the exercises, but that's a property of the parallelogram. Okay, so that equals to that, and that equals to that. So if they give you any two sides, there's only two sides in the parallelogram, or the two different dimensions, because the two sides are equal. So if I give you any two measurements, those are the two sides. If I give you any one of these angles, we can always find the other angle, because remember, these are parallel lines, so these are co-interior angles. So this, let's say this angle is 120, then this angle is 60, because they got to add up to 180. Okay. So basically, again, all we need to construct a parallelogram is two sides and an angle. All right, they've given us the two sides and an angle, so let's try to construct this. So BC is 10 centimeters, AB is 5, and angle B is 30 degrees. Okay, so we'll start with the longest side, BC. I draw myself a construction line, then I measure on it. What do I measure? 10 centimeters, and I call it BC. There it is, and it's 10 centimeters. All right, and then the other side is AB, which is 5, and angle B, which is 30. Okay, this is B, so we need a 30-degree angle here. Right, how do we draw a 30-degree angle without using a protractor? Well, it's a 60 that's been cut in half. Okay, so that's easy. How do we draw a 60-degree angle from B? Well, we set our needle point over here, open up our compass, make a mark. What you do now is put your needle compass point, no, sorry, I'm lying, make a mark there and make another mark over there. Okay, then you take your needle compass point, put it into this point here, make a mark there. Now that, if we join these two, that would give you an angle of 60 degrees, but we want a 30-degree angle, so we need to bisect this angle. Okay, well, we have that point, we have that point. So what we're going to do now is we're going to put our needle compass point into here, open up some arc, make a mark. Keeping the same distance, put it over there, make another mark like that, and that will now cut the 60-degree angle in half and give you a 30-degree angle. Right, now what we can do is we can draw a line which goes through here, and we measure it to be 5 centimeters. Okay, so that's the other line, AB. Okay, this is our point A over there. Right, so now we've drawn our 30-degree angle. We have ABC, no problem. We know how to do this, but how do we get the rest of the figure? Remember, these are parallel lines. How do we make sure that things are parallel? All right, so this is what we're going to do. We're going to join our AC with a construction line like that. Okay. Now what I'm going to do is I'm in a dotted line. I'm going to just imagine what this thing should look like. Okay. So it should look like something like that. Okay, do you agree? So it's a parallelogram, two sides are parallel, so it should look something like that, okay? So what do we notice? Well, we notice these parallel lines, which makes a Z, and Z gives us alternate angles, okay? So what we need to do is we need to recreate this angle over here to be the same as that angle, and this angle here to be the same as that angle. If we can manage to do that, we have our parallelogram, because we can join in these two lines, and then obviously where these two lines cross over there, that's going to be the other point D. All right, so how do we measure these angles? So what we're going to do is we're going to put our needle compass point at A. We're going to open up the compass to some distance, which is not too far, and we're going to draw an arc like that. Okay. Now, keeping the same distance, I'm going to put this needle compass point at C and draw the same arc on that side like that. Okay. With this dotted line, the dotted lines are not there, obviously. So here I've made it perfect, but you're welcome to draw these arcs a little bit further so as to find that intersection that we are looking for. Anyway, let's continue. Well, let me actually take this dotted line away. Okay, we'll come up with these dotted lines. So what I've done is that I've put my needle compass point there and there. I've drawn the two arcs. Great. What I'm going to do now is I'm going to use this angle here. I'm going to put my needle compass point over here at this point and measure up to there. So this will give me the distance of this, well, the third side of this triangle, which will lock in that angle. Meaning that if I can recreate that same distance over there, it can give me that same angle and I can have my alternate angles happening. Okay. So again, what I'm doing is I'm putting my needle compass point into this part of the arc and I'm opening it to this line there. Keeping that distance, I'm going to this point. Remember, these 2 points are almost the same. It's just mirror opposite. So we've measured that much. I go to that point and I measure that much with my protractor, with my compass, and I make another arc over there. Now the intersection of these two arcs gives me a line that I can draw like that. Okay, so I just draw a construction line going from point C, okay, going upwards. Okay, great. So what did we do? We measured this angle here, or the distance, and we recreated it over there. Great. Well, we need to do the same thing with this angle and recreate it over there. How do we do it? Well, we need to measure the distance from the central line to the edge. So I put my compass point over there, open it up this distance, keep it the same, put my needle compass point there, keeping the same distance, I'm going to make a mark. The intersection of those two arcs gives me the point through which the line goes from A across like that. Now the intersection of these two lines will give me the other point, A, B, C, D. And then I can erase that and I have my parallelogram. Okay guys, so that's how we do the parallelograms. The trickiest part is to do this thing with the angles over here. Okay, but good thing this is a video. You can rewind and watch me do it again. Guys, I highly recommend you do this as a practice and you actually work this out, because when I was prepping for the lesson, I read it and everything made sense, and then, well, 5 minutes later, it didn't make any more sense. So you kind of have to really sit there and try to work it out and get good at it. Okay. All right, guys, so that is now example 1, draw a rough sketch. We've done that. Number 2, accurately construct without using the protractor if possible. Draw in the diagonals AC and BD. Okay, we have AC already. We can draw in another diagonal BD. It's doing that. Okay. Measuring the and measure and indicate the lengths of AE, EC, BE, and ED on the construction. Okay, guys, so I want you to, the hardest part was to construct the quadrilateral. The rest of it is just measuring the angles, commenting what you notice. You guys can run through that. And what I want to do is go on to the next section, which is polygons. Okay, so exercise 12.3 is going to be for homework. And let's finish this geometry section with polygons. Okay, so a regular polygon is a plane figure with equal sides and equal angles. Okay, so a polygon is a shape with many different sides. It has all equal sides and all equal angles. Okay, all regular polygons can be divided into congruent triangles by joining the equal sides of the polygon to the center of the polygon as shown below. Okay, so what they're saying is that if we have a polygon, let's say we have a square, okay, word polygon means poly is many and gon is sides, okay, so it's a many-sided shape. So polygon, well, poly here is 4, so a square is a 4-sided shape. So a regular 4-sided shape or a square looks like this. Now what they're saying to us is that if we have the center of this shape, and we can find the center by bisecting the angles, if we take a line from the center to each corner, it will divide the shape into 4 equal or congruent triangles. Okay, the same thing goes with the pentagon. Okay, we have something like that. We have a center, we can join it, and it will give us 5 identical triangles that fit together. Same thing with a hexagon and an octagon and a triangle and so on. Okay, guys, there's a nice little formula. So if the polygon has n sides, then each angle at the center will be 360 over n. Okay, so 360 over n equals to our angle at center. Okay, so let's try it with this one. What is my angle at center over here? Well, what is my number of sides? It's 4. 360 divided by 4 gives me a 90. Yes, those are 90-degree angles. Okay, if we have a 5-sided shape, well, 360 divided by 5, whatever that is, it's 72 degrees. So meaning that this is going to be 72 degrees everywhere. Okay. All right, cool, guys. Let's continue. So this gets us to exercise 12.4. Number 1, A, B, C, D, E, F is a regular hexagon with sides of 6 centimeters. A, calculate the sizes of the angles of triangle RAB and then classify the triangle. Okay, so you basically need to work out the angles and try to classify the triangle that you get. Okay, so you can do that. B, construct the hexagon. So you now need to draw this hexagon, construct. Guys, we know how to make 60-degree angles. Well, a hexagon is full of 60-degree angles. Okay. Right, guys, so what I want you to do is try exercise 12.4, see what you come up with, and in the next lesson, I'll go over it with you and I'll help you construct these hexagons and pentagons. But I do want you to try to figure it out yourself. The pictures are there. I want you to try to actually make them yourselves. Okay, guys, this is quite a short lesson, but let's leave it at that. In the next sections, we're going to continue geometry of 2D shapes. Okay, so it's pretty much more geometry, then more quadrilaterals. Okay, and then we're going to get into the congruency conditions, which is really what the geometry is building up to so far. Okay, guys, I hope you enjoyed the lesson, and I'll see you next time, and good luck with your test today. Cheers.